Today we'll look at matrix multiplication and where it's defined or not defined. So if we consider two matrices A and B, which have a number of rows by a number of columns, then for us to be able to multiply these two matrices, the number of columns in matrix A must be equal to the number of rows in matrix B. And the resulting matrix has the same number of rows as matrix A and the same number of columns as matrix B. So for example, this first matrix has 2 rows by 3 columns, and this second matrix has 3 rows by 1 column. So the number of columns in A is equal to the number of rows in B, so this multiplication is valid, and our resulting matrix will have 2 rows by 1 column. And for this example here, we have 3 rows and 2 columns in matrix A, and 2 rows and 2 columns in matrix B. So the number of columns in A is equal to the number of rows in B, so this multiplication is valid, and our resulting matrix will have 3 rows and 2 columns. And in this example, we have a 3 by 3 matrix multiplied by a 1 row by 3 column row vector. So the number of columns in A is not equal to the number of rows in B, so this matrix multiplication is not valid. Now let's do a couple of examples. So I'm going to copy this over here. So to multiply these matrices together, the first entry of the resulting matrix is in row 1 column 1. So what we do is multiply row 1 of this matrix by column 1 of this matrix, which only has 1 column. So that would be 1 multiplied by 1 plus 2 multiplied by 4 plus negative 1 multiplied by 2. So that gives 9 minus 2, which is 7. And then to get the element in row 2, column 1 of the resulting matrix, we multiply row 2 of this matrix by column 1 of this matrix. So that would be 1 by 1 plus 3 by 4 plus 0 by 2. So 1 plus 12 is 13 plus 0 is 13. So this here is our resulting matrix, which as we said is a 2 by 1. And now let's do this example. So as we determined, our resulting matrix from this multiplication will have 3 rows and 2 columns. So to get the entry in row 1 column 1, we multiply row 1 of this matrix by column 1 of this one. So that will be 1 multiplied by 2 plus 3 multiplied by 1. So 2 plus 3 is 5. And the entry in row 2 column 1 is obtained by multiplying row 2 of this matrix by column 1 of this matrix. So 2 by 2 is 4 plus 7 by 1 is 11. And you'll see a pattern here. So we have the third row multiplied by the first column will give us this entry over here. So 4 by 2 is 8 plus 2 is 10. And then if we multiply row 1 by column 2, we'll get this entry over here in row 1 column 2 of the resulting matrix. So 1 by 1 is 1 plus 3 by 4 gives 13. And then the second row by the second column gives this entry in the second row and second column of the resulting matrix. So 2 by 1 is 2 plus 7 by 4, which is 28, gives 30. And finally, row 3 by column 2 gives this final element over here. So 4 by 1 is 4 plus 2 by 4 is 8, gives 12. So note that matrix multiplication is not commutative, because if we reverse this multiplication, we'd have a 2 by 2 multiplied by a 3 by 2. So the number of columns in A will no longer be equal to the number of rows in B. And therefore this matrix multiplication would not be valid.